Hello everyone. Today we will discuss about binomial distribution. Before discussing with the binomial distribution, we should know what is a Bernoulli experiment. So Bernoulli experiment we can define as it is an experiment which is having two outcomes. One outcome is called as success and the other outcome is called as failure. So what all outcomes we are getting for that experiment, we will be classifying it as two types. One is called as success and the other is called as failure. For example, if you are tossing a coin and we assume the random variable x, which denotes getting a head. So after tossing a coin, if we get a head, we consider that is a success. Otherwise, it is a failure. Another example, if you're considering, if you're throwing a dice or tossing a dice, and the random variable denotes if you're getting a even number, it is a success. So obviously, if you're getting a odd number, it will be as failure. So in this way, we are classifying the outcome of the random experiment as two types. One is success and the other one is failure. And the probability of getting a success in each trial or that trial we consider as P. And probability of getting a failure with the term Q. So the total probability either success or failure can happen in an experiment. So the total probability P and Q is equal to 1. So if P is given, we can find the probability of failure, that is Q, is equal to 1 minus P. So in Bernoulli experiment, we are performing that experiment only one time. And the same experiment, if you are repeating n number of time, then the probability of success is distributed in such a way that it follows binomial distribution. So a binomial experiment is a Bernoulli experiment which is repeated n times. And the binomial distribution is used to obtain the probability of observing X success in n trials, with the probability of success in single trial is P. So here we will be finding how many success we are obtaining if we are performing that experiment n number of time. The binomial distribution assumes that P is fixed for all trial. How many times we are repeating that experiment? That means if you are repeating that experiment n number of time, each time or each trial, the probability of getting a success is fixed, that is equal to P. And for a binomial distribution, the parameters are n and p, where n is the number of trial and p is the probability of getting a success. Next was the definition of binomial distribution. So we will be defining the binomial distribution with the help of the probability mass function, which means how the probabilities are distributed among themselves. A discrete random variable x is said to follow binomial distribution with parameters np if its probability mass function is given by p of x is equal to ncx p raised to x q raised to n minus x, where x is equal to 0, 1, 2, etc. up to n, equal to 0 otherwise. That means if x takes any values from 0 to n, n means the number of trial. Suppose if you are performing that experiment 5 times, so the possible values of x will be from 0, 1, 2, etc. up to 5. So if x take any value 0 से लेके n तक, then the corresponding probability will become ncx p raised to x q raised to n minus x. And if x take any other value other than this range, its probability mass function is equal to 0. And we can define or we can denote the binomial distribution like x follows b and p. So this we can read as a random variable x follows binomial distribution with parameters n and p. Next is the properties of binomial distribution. The first property is about the mean of a binomial distribution. The mean of binomial distribution is n into p, where n is the number of trial and p is the probability of success. Second, variance of binomial distribution is n into p into q, where n is number of trial, p is probability of success, and q is probability of failure. Now let us see one question. An unbiased coin is tossed 4 times. Calculate the probability of obtaining. First question, no head. Second question, one head. Third, at least one head. Fourth, at most one head. So first of all, we have to define what is the random variable here. So for defining the random variable, we have to look into the question. All questions are asked in terms of head. One head, no head, at least one head, at most one head, like that. So we define the random variable x as number of heads obtained in 4 tosses of an unbiased coin. So if you're tossing a coin 4 times, then the possible value of x is 0, 1, 2, 3, 4. So based on this, we will be having the number of trials or the number of coins here we have is 4, n equal to 4, and it is also given the coin is an unbiased one. So if the coin is unbiased, the chances of getting or probability of getting a head is equal to 1 by 2. So P we can define as P is equal to 1 by 2. So P is 1 by 2. Therefore, Q is also equal to 1 by 2 because Q is equal to 1 minus 1 by 2 equal to 1 by 2. So now we have the value of N, P and Q. So we can define what is the probability mass function of this experiment. So P of X is equal to 4Cx 1 by 2 raised to x and 1 by 2 raised to 4 minus x. So the value of x is equal to 0, 1, 2, 3, 4. And our first equal to 0, otherwise that condition is also be there. Then our first question is probability of no head. That means the number of head is equal to 0. So P of x is equal to 0. So in the place of x, we'll be having 0 because the x denote the number of heads. So 4C0, 1 by 2 raised to 0, 1 by 2 raised to 4 minus 0. So we know 4C0 is 1. 1 by 2 raised to 0 is also equal to 1. 1 by 2 raised to 4 is equal to 1 by 16. Then the second question is probability of one head. So probability of one head means P of x is equal to 1, which is equal to 4C1, 1 by 2 raised to 1, 1 by 2 raised to 4 minus 1. So 4C1 is 4, 1 by 2 raised to 1 is 1 by 2, and 1 by 2 raised to 4 minus 1 means 1 by 2 raised to 3, which is equal to 1 by 8. In short, we can write it as 4 into 1 by 2 into 1 by 8, which is equal to 1 by 4. The next question is about at least one head, probability of getting at least one head. So probability of at least one head means minimum one head is required. So symbolically, we can represent it as P of x greater than or equal to 1. So P of x greater than or equal to 1 means it will have the value 1, 2, 3, 4. So we are using a complementary statement of that, which is equal to 1 minus P of x less than 1. Because here we consider greater than or equal to concept. The remaining is only less than. So the complementary will become 1 minus P of x less than 1, which is equal to 1 minus P of x equal to 0. So P of x equal to 0, we already calculated. Then you substitute the value 1 minus 1 by 16 equal to 15 by 16. And one more question is there, that is probability of at most one head. At most one head means P of x less than or equal to 1. At most means maximum. So we will be having maximum one head. So less than one head is also possible or equal to one head is also possible. So we can write it as P of x less than or equal to 1, which is equal to P of x equal to 0 because two possibility less than 1 means one will be 0, other will be equal to 1. So we have to take their probabilities together. P of x equal to 0 and P of x equal to 1, we already calculated. So those value we have to substitute over the 1 by 16 plus 1 by 4, which is equal to 5 by 16. Thank you.